The last speaker of this session is going to talk about the SIL genetic engine. Mark Young, as you will well know, has been involved with SIL for 13 years. He graduated his undergraduate degree from Lincoln, his PhD from Lincoln University, and then did an animal breeding master's in Edinburgh University. He set up the CT scanning at Lincoln University and the Scottish Agricultural College in Edinburgh, and taught animal science and animal breeding at Lincoln University. He's an animal breeding scientist at SIC in Scotland, and has particular interest in growth, development and meat in animals. Mark Young.
Some of these topics have been alluded to by other people. I want to just focus on the evaluation system. So it's the service you're getting as SIL breeders. And the big theme we want to look at, it's a fairly bold aim here, is we want bigger, faster, better genetic evaluations. And the way we're going to do that is aimed to have a single all-SIL evaluation. At the moment, you do evaluations with groups of flocks that you're part of, but we're thinking that we can get much more value from having a single evaluation that has everything in it. And we'll have a look at quite what that means. So the issues we've got to address to achieve that is we've got to be able to work with larger data sets than we can at the moment. So there's some software, hardware issues there, and also get a faster analysis time out of it. We can't have it taking weeks or months to do an analysis. At the moment, the biggest analysis we do is SIL ACE, takes about a week to perform. We want to do an all-SIL analysis in less than a week. We want to get more automated data processing to speed it up because there is some manual intervention at the moment, and we also need to make sure there's data integrity checks. We're getting to a point now we've got data coming from different sources. The model that SIL was set up with was performance and pedigree information from farm and within flock analyses, with some across flock analyses. We're now getting information from other sources, the genomic data. Pedigree tests might be coming in. So what do you do about the pedigree that's recorded on farm? We need to have some checking systems in place to make this system work efficiently. We also think that connectedness, which is currently thought of as being, are these flocks connected and should they be in the evaluation together, we're actually going to shift that to being a reporting issue. We do the analysis of all flocks, and whether they're connected or not tells you how to report and interpret the BVs. So we're going to shift the emphasis there. And what we're trying to do is overcome the problem with too many different sets of BVs. Now, a number of people in this room have interacted with myself, with Sharon McIntyre, who's here, and Tim Byrne on a few occasions, with why are these BVs different to this other set of BVs I've been sent by someone else? Or from one analysis for my group breeding scheme versus the one I've had done for my flock? Or why are they different to SIL ACE? So we've got to actually overcome the problems we have with that, which is the fact that you've got different sets of data being used to estimate any particular set of BVs to another set of BVs. So for those too many different sets, you can just really labour this point. We've got EBVs. You can have some people are still doing within flock analyses. It suits them. It's working for their operation. Others are doing within flock analyses, and they're bringing in the data from the flocks that they've bought rams from, because they're worried about those outside sires having missing information that compromises their breeding values, and more importantly, in a business sense, the breeding values of their sons that you might be selling you will be selling as a ram breeder. We then got across flock breed groups of varying sizes, and the largest across flock group we got is the SIL ACE. Although the new national genomic evaluation, which John McEwen alluded to, has been introduced, and that has about 100 flocks in it. That's a big data set too. SIL ACE at the moment is about 350 flocks. We've then got a different type of MB that's a new kid on the block. We've got the MBVs coming through from the DNA tests. So you can get breeding values on animals that have no performance information in this way. And then we've got what was talked about with the blending of the MBVs and the EBVs together. We've got a thing called a GBV. So if you go on SIL, some sheep have got multiple sets of EBVs, they've got MBVs and they've got GBVs from the latest national genomic evaluation. And it's not surprising the question that we get is, why are these BVs different to those BVs? So as a quick head count, what should we be doing with all the information we've got and in terms of this sort of thing? Are you happy that we say one set of BVs using all the information we've got? Excellent. Sold. So we've got many EBV sets, and so the way we're going to do it, if we look at the current system, in some respects it looks like we're not changing much, but there are some fairly fundamental things under the hood. We've got 4 major elements at the moment. We've got a master database. We've then got some tools which prepare data for an analysis. That goes to what we call the genetic engine, which is basically the computer that analyses the data. And then the BVs that come back are stored. Now, when SIL was first set up, they were stored on the master database, but because we had this proliferation of sets of BVs, some of which we want to retain, we set up our own database just for BVs. We've then got the reports sent to you or your bureau by email, and we've also got some online search tools at the moment, so you can make limited searches through the SIL ACE dataset, find out some information there. What happened in the last few years is we've seen this information where the genotype data comes in, the MBVs are generated, they then get exported with EBVs to a separate system that blends them together based on their accuracies and then reports them back to SIL. So you can see the SIL BV database has got all these different sets of BVs. And as I mentioned before, you can have EBVs from a Coopworth analysis, a Frontier genetics analysis, an Alpha genetics analysis, a SIL ACE analysis, and a within flock analysis, all for the same animal, and you've got weaning weight BVs from all these different situations. What we want to do is we want to just refresh what we're doing by getting the key thing is the genetic engine. It has to be able to handle data from different areas, and we also have to have a genomic database. We've got fewer animals in the sheep industry in New Zealand, and we've seen a slight decline in numbers on SIL. The DNA has really opened up this tidal wave of information that's coming at us on the beach. And so we have to be able to handle that. We're going to need a very specific database that will make efficient use of this very dense information that we want to use routinely in evaluation. So we need a very customised database. Unfortunately, the person who represents the group that will be leading the work on this, Andrew Cook, his plane's been delayed, and I'm hoping, cross fingers, he'll be here this afternoon if anyone has particular questions about it, because this relates to how you might think about the uses you might want from some of that information that's above and beyond just getting BVs. So we're still going to have the same elements where genotype data goes into a database, but this database is going to talk directly to the genetic engine. We're also going to get the pedigree and performance information coming in, and we're going to get one set of GBVs, and I think that was the diagram that Michael put up a representation of. So rather than lots of sets of BVs, we're going to routinely regenerate a new set of GBVs from the information available. As well as that, we want to develop better industry tools, not just variations on what we've had so far, but we want to look at better ways of using information. We might have some simple tools that help you check pedigree errors to do with parentage tests and resolve issues, that sort of thing online. We want to be able to use information for ram buyers that says if I use rams with this sort of genetic merit from this sort of flock, what will it do to lift my progress in what I'm making as a commercial farmer? So there's other ways we can use information that delivers more value to industry. So the key benefits, we think, by making these changes, and I'm talking about the genetic evaluation system. Now, this is the whole infrastructure that generates BVs. There's another one key element in it, and there's a thing I call the genetic engine core, and that's the subject of some work that's being led by Benoit Ovray, who's here and will be talking to a poster this afternoon, and that's where the actual computer software that analyses the data, it has to be able to cope with the pedigree data, the performance data, and the DNA data all in one big analysis. That is a very, very significant investment for us to get that to happen. And that piece of work is a critical part of this. But we've also got a whole lot of infrastructure around it, like the database and how different sets of data talk to each other and are validated against each other. So we're going to have one valuation, so we don't have the variation between these different sets of BVs. And that means instead of saying, why are these BVs different to that, we can actually say, what's the best way to use these BVs, tying in with the work that Peter was talking about with the economic indexes. It will give us the most accurate set of BVs available, because we're using all information. And that gives us that better focus on using genetic information, which must mean we're going to get faster genetic gain. Thank you. Was that quick enough?
When?
Sure. This is a 5-year program of work. We expect to be able to have large-scale evaluations without that change to the core bit. So using the current evaluation system, a variation on it with the whole of SIL, we like to think we'll be testing those analyses within a year. When we roll it out commercially, will depend on what the answers of that test are, but the people who work with the software are optimistic we can speed up an analysis and do a whole analysis in less than a week within a year. The question I might put back to you is, you're used to analyses on demand, right? You send your data in, the BVs can come back very quickly. We might have to have a system where the BVs are done every Friday, they're released. Happy to give feedback on that during the meeting. Another question?
Mark, you're
Alan.
combining all these BVs together, but we know that when you put animals from one environment into another one, those BVs don't actually translate into the performance.
And that's the question that Michael Lee was talking about.
Yes.
So it may be, the sort of simple rule of thumb is, if animals rank differently for genetic merit in two environments, you really need two BVs. And the way I would describe it in the context of the example Michael gave, the weaning weight BV in an FE environment is not genetically the same as the weaning BV in a non-FE environment. So that is part of our program, is to address that sort of issue and also quantify that difference between to what extent a some of our better rated sheep, will they deliver that also on harder country?
So are you going to end up with two BVs and a high and a low input?
That would depend on the nature and the magnitude of what we say are these effects of environment. Completely, you can't use this genotype in a hard environment. It's well suited to a low environment. The international literature suggests those effects are there, but they're not huge, meaning they're modest.
Mark, mightn't it be better just to put your BV for FE in not a separate column, but that be the determining factor for above a certain threshold for going?
It can be. It's one of the things that I think is perturbing some of the BV ratings for animals from down south versus those up north, is that you really have to know which link size are used in which direction, because it can influence how animals rank relative to the other in and outside FE environments.
Mark, you mentioned,
Gordon.
facial eczema.
Yep.
But there are I come from North Auckland, a whole lot of other factors like pneumonia, cattle pick and so forth that affect everything. I mean, when I have 10% of the lambs in June weighing less than they weigh at weaning, there's a very significant environmental impact.
I think a breeder from the Wire Rapid summed it up beautifully for me after a meeting we had talking about these environment by genotype interactions. He said, don't confuse being on a hill with it being hard. And so what you're saying is it can be hard for other very good reasons.
It can be hard and healthy.
Yeah, I can't cover all of those things you talked about, but I know there is a poster specifically about a proposal for a project in the area of pneumonia in sheep and genetic merit.